GraphQL, an explosion of complexity. Wow, that escalated. Okay, hi everyone. My name is Michael, front-end lead at Meister, currently building Meister. And I am here today to tell you a story about GraphQL. And I will try to paint you a picture of what it looks like when you have no idea what you're doing. You're using it the wrong way and all of a sudden it explodes in complexity. The main takeaway for you here should be to recognize when something similar is happening to what I'm going to show you for you and your applications, for you to be able to reconsider your approach and do your research. Now, but there are a number of tools available for GraphQL. There is, you know guys, Apollo, there is Eurocool, there are even things like React Suspense. I am not going to talk about any of these things. I just want to talk about GraphQL and plain JS. Now, before we jump in, I want to quickly show you guys what GraphQL actually looks like, just in case. Let's make an example. Let's say I want to fetch a list of tasks, right? A list of to-do items or whatever. And from each of those tasks, I want to just fetch the title. And here at the top is what I could describe what I just said in plain text. Okay, so I fetch here tasks, and from those tasks, I want the title. This is GraphQL, that's it. I can send this as a string to the server, and here at the bottom is what I could get back as an example from a server. This is GraphQL in a nutshell. It is just a way for you to describe what data you want to fetch. Let's say, for example, now from this point, I want to fetch IDs from my tasks as well. I can just go in there and say, hey, I don't just want to have the title, but I want the ID here as well. And I will get it simply here in the response. I can also describe what kind of relational data I want to have. Let's say, for each of those tasks, we have tags, high priority, low priority, front end, back end, design, whatever. And I want to fetch those for each task. And let's say for whatever reason, I want to fetch the person who created each tag as well while at it. With the help of GraphQL, I can just simply describe this in plain text, like so. And I will just simply get this here in my response. GraphQL is a query language. It's a way for you to describe exactly what kind of data you need, no matter where it's coming from or how it is constructed. This makes GraphQL extremely flexible. It is a wide canvas, and it can be used for many different things outside the context of fetching even. It is a really nice way for you to say, I need exactly this data in one single go. Now, the thing is, especially when you create a new app, right? Maybe an MVP. You might really appreciate this. You might really appreciate the ability to just say, give me everything in one single go, and not necessarily prioritize optimizing fetching data from day one. You're not going to do that, especially when the definition of your product is questionable and your product is still a heavily moving target. And you guys know how things go with technical debt, right? You don't touch things until they are broken. So this is my dashboard in MeisterTask. Basically, just on the left side, you can see I have a bunch of projects there, personal ones for my work. And inside each of these projects, I have tons of sections, as you can see, those vertical columns. And within each of those sections, we have a bunch of tasks, a bunch of stuff I still need to do. And then finally, this is the content for just one of those tasks. So you guys can see we're dealing with quite some data here. And at some point, your application just grows so large that this give me all my stuff approach is no longer going to work. And we have a massive loading performance here, a massive loading performance problem here. So what can we do about it? Well, one very simple quick win. If you started off with just give me all my data that I have, well, at least one quick win could be you split things up by your three, in this case, 3 major big views, right? Quick win. So here I have roughly split up what was previously 1 mega fetch into 3 completely isolated queries for our major views. So for example, when I enter the dashboard, this is exactly the data that I need to display the dashboard. And when I enter one particular project, this is exactly the data that I need to display the project. Now, when I enter a project, or when I enter my dashboard, I no longer have to fetch all of my tasks. This is way better, much better. But is this good enough? Or was this good enough for us at that moment in time? Not at all. Not at all. If you observe closely, we fetch this user data here more than once, right? For us, fetching this data was extremely expensive. Extremely expensive, and we're fetching it 3 times here. Now, what can we do with this? Oh boy, here we go. Okay, so if I'm currently fetching this query A, and I now want to fetch this query B here, we can understand that we have the same field user in both of these queries, and we can understand that once query A is in flight, once we want to fetch query B, we don't need to fetch user again. That is already being taken care of by query A. So we actually built a tool that, given 2 GraphQL trees, can walk through the GraphQL tree and splice out the duplicates it finds along the way, which really wasn't easy to build, but we did it anyway. Okay. So we had now our 3 isolated queries, while at the same time not fetching the same data more than once unnecessarily, at least for basic scenarios like this one. How about now? Is our app fast now? No, not at all. We still have to fetch this one at least once, right? We still have to fetch this one at least once. And this one by itself, even if we only fetch it once, is extremely expensive for us. All right, what did we do next? Well, the lucky thing about user data, first name, last name, when did you sign up, etc., is that this is not exactly data that changes every other week, right? People don't marry every other week and change the last name or whatever. This data is perfect for caching. So let's say we had a way of marking this user field as cached. Something like this. This is pseudocode, something like this. What we can do is the first time we fetch all of it. But once the response comes back, we can take the part of the GraphQL tree that we marked as fetched, and we can put it, for example, in local storage, just like so. So nothing special is happening there quite yet. The next time we fetch, we can understand that we have data available in our cache, so we build yet another tool that can split up that one query that we had before into 2 pieces, transparently under the hood. So it split that query up into 2 pieces, one piece containing the data that we don't need to have cached, and another query with only the things, the expensive fields that we wanted to cache. This one, it would send off, and once the reply comes back, we can just simply tag on the missing pieces from our cache. Meanwhile, this query B would run in parallel in the background. At this point, the app is already ready to go. People can already use it, and once this query B comes back, the app will just simply update. All right, how about now? We built a bunch of fancy tools. We split our queries up, we deduplicate selections, and we have caching at any level of our GraphQL trees. What about now? Is our app fast now? No, not quite yet. We are not quite there yet. It's just a volume of data that we need to load. It's just so big. We can't add there's no more room to play with caching anymore. Caching is perfect for infrequently changing data. So what can we do next? High prior versus low prior. So each of the 3 views that I showed you before, the dashboard, project, and task, we split that up into 2 additional slices. High priority data, low priority data. The app is only ready to go, so the app will only wait for the high priority data. Meanwhile, in the background, we would fetch low priority data. I just wanted to really quickly show you what kind of queries we're talking about here. I mean, imagine having to walk through something like this, and not only deciding what is high priority, what is low priority, but also, you need to maintain this, right? And you need to make sure it works nicely with selection, deduplication, and you have to figure out which things can be cached and which things cannot be cached. But okay. So the current state of the art is we fetch only high priority data. We split up our GraphQL trees into multiple trees, cached queries, non-cached queries. We have selection, deduplication. We build all these fancy tools. Okay, how about now? Is the app fast now? And for us, actually, finally, at this point, it was decently fast enough for us. But unfortunately, we were hit with our biggest issue yet, user experience. This friend of ours, that every one of you knows all too well, I think, we had this one everywhere, even in places where we didn't expect it. Why is that? The thing is, the biggest deal breaker in fetching, it sounds a little bit funny, but it's true, is to not fetch at all. And in order to not have to fetch, you must be able to answer one simple question. Did I fetch this already? Or am I currently fetching it? And this is where things for us finally started to fall apart completely. Here are some ways, not all of them, I have limited screen real estate to work with, there's more. But here are some of the ways where I can fetch one single task, or one single to-do item, however you want to call it. We have a little bit of a problem here. When I fetch all tasks here, for example, this is what this is supposed to mean, give me all tasks. And I wanted to afterwards fetch a particular task, by its ID, for example. GraphQL does not understand that this is not necessary. GraphQL has no knowledge, no understanding of supersets or subsets or anything like that. And it's not even GraphQL's job to do so. That's on you. It's how you design your API. There is no magic tool this time that we could build to get us out here. Neither did we find anything existing that we could use to save us from this one. Instead, we have hundreds over hundreds. You guys don't want to see that. We have hundreds over hundreds of lines of code that try to figure out if a task needs to be fetched or not. For example, we have code that given one task ID, we would check if it was fetched by its token already. And token, by the way, is a random string that we would put in URLs. You don't want to just expose your primary database IDs in the URL bar. So it's just a randomly generated string for each task. So it would check if we fetched it by its token already. It would check if we fetched open tasks, and if so, if that ID was included in these open tasks already. We would check if we fetched this particular section from this particular project with this token, if that task was included in this query. We would check if it was included in this particular section, maybe in this particular subset of all tasks, archive tasks. We have tons and tons of code to check for all possibilities. An additional thing that does not help here at all is that I mentioned before, GraphQL is a white canvas. You can do with it whatever you want. And you can go really nested here, for example. I can go from projects, I can walk down to sections, down to tasks. I can walk the other way back up as well if I build my API like that. I can ask, give me the section this task is in, and give me the project this section is in. So you can go bi-directional. You can do whatever the hell you want, and this stuff is really convenient. It's really convenient once you play with it. But this just makes understanding what you're fetching and what you already have fetched much more difficult to figure out. So this was the end of the road for us. We were unable to make any kind of predictions. We had to fetch data in order to be able to tell if that data fetch was necessary. All right. What now? Okay. I was just joking. Let me try again. If you find yourself in a troublesome situation like that, maybe not exactly what I am explaining to you here, painful in similar ways, maybe. I want to show you and try to explain to you what we've done recently that was so far quite successful. A couple of steps. First of all, identify your primary models. So that's your most important models that keep popping up everywhere. In this case, it might have been tasks, it might have been sections and or projects. Identify those, write them down. Have only one single way of fetching them. Not a dozen of different possibilities and combinations and up and down that I showed you before. I will show you exactly what this actually looks like, but have only one single way of fetching a task, for example. For your primary models, the most important models that you have. Try to stay unidirectional. I just mentioned this before, but try not to be able to walk from top level to bottom level, from project to task, and from task back up to project. It is really convenient, but in this case, it can make stuff really difficult for you. This might be slightly controversial. I will explain in more detail later. But GraphQL just makes it really easy for you to fetch data in one single go. Give me all of this data in one single go. But this is still a valid case. This is still a valid case, and I personally really appreciate this ability to fetch everything in one single go for low priority data, for example. But in serious scenarios like this, when it comes down to optimizing your performance as much as possible, don't be afraid of going a little bit old school and fetch data in multiple steps, not just in one step. Finally, try to build small pieces, fetches that fetch small areas of data and compose them together to build more complicated scenarios. Now let me show you in more detail what I mean here. I hope you guys can see this one. This is now the only way I can fetch tasks. The only way. I can only fetch tasks by a list of IDs. If you think about it a little bit, this is absolutely trivial to deduplicate. Right? I'm dealing with an array of integers here. I can deduplicate easily. This is trivial to parallelize by means of chunking if you need to. It's trivial to cache it in local storage or whatever you want in a service worker. It is that simple to ask the question, did I fetch this task already? Well, yes, in this case, obviously, I don't need to do any kind of GraphQL tree comparisons or whatever. This is a deal breaker for us. It is extremely trivial to skip the fetch altogether and resolve from local state, whatever kind of local state you have instead, whether that's MobX data, whether that's a plain global variable, if you're still doing that, if it's a Redux store, doesn't matter where it's coming from. I can skip this fetch if I got this task already from wherever, maybe a WebSocket connection that's sending me updates. We don't need any fancy tools here. We don't need query deduplication or something like that. We don't need to split up our GraphQL trees in order to handle caching or anything like that. There is one problem here. There's just one problem. What do you do? And this is all nice, right? So I can fetch a task by a list of IDs, but what do I do when I just have nothing else available to me except the project ID, for example, or the task token? I only have the URL about the token, maybe only. What do I do then? This is where the thing comes in, where I said before, don't be afraid of making extra steps in between. So here I added 2 queries. I get given a list of tokens, I get from the server back a list of IDs. And if I just happen to have nothing available to me other than a project ID, I can get a list of task IDs from the server back, and all I have to do is pass them to fetch tasks by IDs, what I just showed you before. Once again, this is absolutely trivial to handle deduplication. As I mentioned before, this is trivial to cache. For us, the relationship between IDs and tokens is forever immutable. So technically speaking, I can fetch this once in my life, cache it forever, for all eternity, and this data is immutable. I will never have to fetch it again. is really flexible. This is really, really nice to use for predictive fetching as well. So that means incrementally fetching more and more pieces of data, like predicting a little bit what the user is likely to require next. And you can do so in smaller pieces, you know. First fetch the relational data, tokens to IDs, IDs to tokens, whatever, and you can fetch more and more data. Build complicated things by composing many small pieces like that. And it's really easy to do, you know, mostly just dealing with promises just like that. Give this a try, play with it. See if that approach helps you out. Or you might be scratching your head a little bit maybe and asking yourself if that wasn't how REST was working actually. Actually not quite. This is the best of both worlds. First of all, GraphQL goes a little bit further than what I'm just addressing here, right? GraphQL has other things going for it, which are mutations and subscriptions, etc., which I'm not talking about here. So I'm not asking you to go back to REST at all. In fact, you probably shouldn't. And this approach, what I told you, this splitting up and this doing multiple steps, etc., only consider it for internally hypercritical things in your applications. You know, those key models that are extremely important for you when it makes sense for you to invest extra time to optimize this stuff. Otherwise, guys, have fun with GraphQL, go nuts. All right. Thank you very much for bearing with me. I hope this was digestible. Thank you, guys. And I'm curious to hear your stories. One second, please. I'm curious to hear your stories, your problems, your solutions. Or if you just want to tell me how I am ridiculously wrong about any of this, that's perfectly fine. I'll be here afterwards in the garden to hang out with you guys. Yes?
2 questions. Your last step, actually, or the step before last step, actually means that you're only fetching full models anymore. So you will not make a GraphQL just to get the task title. You would always fetch the full task, right?
It depends on your situation. So you mean basically, for example, these tasks.
But what you mentioned here is that if you already have the task loaded, you don't load it again.
Yes.
But that means that you always fetch all the fields of the task and not just one field.
You don't have to. You don't have to. So you can, for example,
let's this API, you don't know that the first one only needs the task title,
yes,
and the second one needs the created ads.
Absolutely, yes. We don't like partial model fetching. We don't really like that. It just adds a ton of overhead for us, and we don't know any decent solution right now other than using something like React Suspense. So the problem here is, what do I actually need from a task? Right? Just by looking at this, I don't know. It depends on what you want to render, right? That depends on what you want to render, what your components actually need. And so far, to my understanding, the only thing that can potentially help out with this in a nice way is something like React Suspense. But other than that, we just say we fetch the full model. Or let's say we fetch the model partially, but we stick to that always, everywhere. So it doesn't matter. So if I need to fetch, let's say 3 fields or whatever, if whatever I'm getting in from the WebSocket, if it at least included those 3 fields, you're good. If it included more than that, you're good. So does that answer your question, hopefully?
And the second one is, I think a quite obvious solution would be to use some kind of background sync task where you instantly load the website based on the latest cache data.
Yes.
And then update with data.
There is one difficulty there.
Why not?
There is one difficulty there, which is the user. So the idea would be, let's make a stupid example, right? Let's say I open an application of mine and I interact with it, and I dump the entire state tree, let's say. into local storage, let's say, for the sake of argument. And the next time I enter the application, I reload from local storage, right? You don't need to fetch anything there, right? Awesome, our app is there instantly. The user can meanwhile interact with stuff, can create temporary models, like when you optimistically create data, and you don't want to, like when you create a new task and you don't want to wait for the response to come back. So you have stale, dirty data everywhere, perhaps in a state tree. But the problem is when you refresh in the background, right? That might have been your intention to refetch the data from the background. Now you need to do diffing. Now you need to try to figure out which data from the cache is no longer valid, and you need some sort of system to figure out which things do I need to kick out. Let's say, for example, I have 10 tasks or whatever, and I have access to those 10 tasks, and I load those from cache. Meanwhile, you maybe remove access for 5 of those, so I no longer have access to those 5 tasks. Now I go into the app, I still have those 10 tasks that came from cache. Now you fetch, now you need to do some diffing there. You need to understand I have 10, I'm supposed to have 5. Somehow...
Well, you don't have to do a diff, you would render the latest stage,
Yes.
the latest cached data.
Yes.
In the background, make a sync, and as soon as you get the new data, you would completely replace it.
Yes, now that is why I brought in the stale temporary data that the user can meanwhile create. So I have those 10 tasks, and I create an 11th one. Now the sync comes back. If I just simply replace it, I just lose the 11th task that I just created. I only have those 5. That's the problem.
I think the way, I don't know. I mean, a few months ago, for fun's sake, I looked how Asana is doing stuff, and as far as I could see, the way they do it, they do not execute your actions until the model is synced, but still show you the latest data instantly.
Yeah.
And then they wait for the sync to complete, and after that, they execute your new.
Is the interaction of the app frozen meanwhile?
No. It just says, I don't know, 2 things to sync.
Do you know what
it
they use
is
for it?
banner.
Do you know what they use for it? Is it GraphQL or do they use something like Apollo for it?
I don't know detail.
But you get me also an idea, like you could, like if you use something like Redux, for example, you could maybe like just simply replace the state as you do the background sync, but those actions meanwhile that ran, that the user used, you can just replay them on top.
So Apollo has, since the previous major version, something called optimistic updates, optimistic mutations actually. Yes. You've seen it?
Yes. No, I'm not sure if I mentioned that, but optimistic updates, I did mention it, yes, but not in the context of
Sounds
support.
like this is what you guys are discussing, because if you can have your UI transparently follow the local state, which partially represents the database state. It could be out of sync. You should always assume it is out of sync. And you send your mutations, and if something along the way fails because the network is down or whatever your authorization, then in these optimistic update mutations, then Apollo will automatically roll back your local state, which will automatically roll back the UI. Also, this will happen. Also, with the sync that you guys were, background sync that was being discussed here, it sounds, and especially since you fetch all the whole model, which kind of a little bit defeats the one of the benefits of GraphQL is that you can partially fetch stuff. But I get the point. It's also like this. Sounds like a Realm.io or a RealmDB. Have you heard of this? It's I think another German project. So it's
RealmDB.
RealmDB or a Realm.io, I think is the website. I've seen it 4 years ago.
Okay, you can see it actually.
Also got quite a bit of funding this time.
Like this? I can.
Oh yes, this one. Oh, they're bought by Mongo. Okay. So this is again very helpful if you have. I was looking for this for a startup project I was working on 4 years ago. It practically does background sync. It solves the collisions that you were talking about, being out of sync and two people change the same title of the same task.
Yeah.
I haven't followed it since a long time, as you
Yeah, I
said.
see.
But it will do all this background syncing of a lot of data and storage, and no matter what if it is a mobile app, like a native mobile app or web or whatever, it will. The client side of this and the server side of this, this is what it covers. So maybe this sounds like it overlaps a bit with stuff you have implemented.
I'll make my notes for sure. Thank you for the tip. One gentleman here has a question.
My first question was actually the same as his
Yes, okay.
about the tasks being fetched. That you basically have to fetch everything you ever gonna need. You answered that already. But there's another question that came up now. This Realm database, do you happen to know what kind of storage they use? Did it just dump it into local storage?
Well, it's over there. You can see it's SQLite.
Probably configurable, I would imagine.
iOS seems to be like core data. It says for iOS you can use core data or you can use a SQLite database.
So you need some sort of local database. You can't just use it on your smartphone or something like that.
I mean the web has already SQLite, which is a database in the browser on the client side.
Yeah.
And apparently,
Friendly alternative. That's different.
and iOS, I believe, or was it Safari that actually at last they had implemented the spec differently because they felt like it, because this is what Safari does these days. I'm sure the front guys are feeling the pain that I am. But they actually brought it up to spec. Regardless, this seemed to handle it transparently. In a different project, in an older company was working, some other guys have used it with no complaints. In a similar scenario, we were fetching practically a copy of the database, because this sounds like what is happening here.
One thing maybe I can quickly show you guys, which is quite interesting, that we found recently. There's actually a broadcast channel API that exists out there, and it's quite interesting in that you can have one, it's sort of like a shared worker, if you guys know that one. You can have a web worker running that works across more than one tab. And this is something similar where you can send messages across different windows and tabs and stuff like that. And you can use that to share state maybe. You can use that to have one single socket connection, for example. If you have 3 tabs, you don't maintain 3 different socket connections, one for each tab, but you could have one master tab. And that one tab handles the data fetching and gathers the state, etc. And all the other tabs can sync through this broadcast channel, which is interesting. So basically the idea would be if you have one tab open, you guys probably know how it is. I cleaned up okay, you can't see it anyway, but I have usually dozens of tabs in one single window open. And for those that I use very often, I probably have 5 tabs open. Technically speaking, what we can do with this one is as soon as I open another tab, I don't need to fetch anything, but I have state-of-the-art from another tab. Nothing stale or anything, nothing that needs to be synced or whatever.
Have you used this?
We don't use this right
right
now at all. I'm trying to find, there's one very interesting package which I'm trying to find, but I can maybe talk to you guys about this one later. Are there any other questions? Oh boy, okay. Let's start here, this gentleman.
Yeah, first, thanks for the presentation. That was really great. If I may step outside the technical layer for just a second, I was wondering if if the moral of your story is also kind of a bit of a lesson in information architecture and interaction design, or did I interpret that a bit wrongly?
Yes, so I kind of don't want you to take my words for granted, basically. I don't want you to do that, I'm also just I mean, I screwed up a bunch of times, as you know, right? So there are lessons to be learned here in architecture, in self-management, for example. You know, prioritization, doing research before you do anything, right? We didn't particularly, you know, we didn't particularly take a deep dive into GraphQL API design, you know. We just went, oh, GraphQL is awesome, it's cool, let's jump in, let's use it, you know. And here we are. Here we are, and then even once we started to notice that something was wrong here, you know, the tools that we started to build, that was also already the wrong approach. That was already a red light for us to say we are doing something wrong here. So yes, technical debt, doing your homework before you do anything, a little bit into that direction as well, yes. Absolutely, more important probably than what I tried to show off here actually. Yes?
So I was going to ask why not just go back to a REST API, but you've already addressed that.
Yeah.
So there are other benefits of GraphQL you haven't spoken about,
Absolutely.
which I get that. So let's say you're starting your next project. You're going to start with GraphQL.
Yes.
And I get your initial point, which is that for initially filling out the project, it's a very quick way, you know, just like the early days of Ruby on Rails. It's like you throw something together quickly and then make it better later. But having learned what you've learned, I wouldn't say you've wasted time. I'd say you've spent a lot of valuable time looking for approaches to optimize and then discarding those approaches. That's still valuable.
Yes.
But I would say, based on what we've learned, what would you do differently next time, right from the start?
In terms of choosing between GraphQL and the alternative?
No, in terms within GraphQL, what would you then do to avoid some of these minefields?
If I'm honest with you, I don't think it was a bad choice to start out with the simple approach. Give me everything.
Yes.
As I mentioned before, especially when your product is a moving target, a heavily moving target,
Absolutely.
and you can't even identify your primary models quite yet.
Okay,
you know?
but the point comes when you need to optimize that.
When?
So what
Yes.
would your strategy be that's different this time?
I wouldn't particularly do anything different. What I would do is that I know that this can happen now, right? And I know what the potential solution could be. And what I would at maximum, so at minimum, you should inform your team, right? You need to inform your team that this is something that can happen, and you have a suggestion and you have solutions, proposals already to go. But no, you know, you don't prematurely optimize. So I would at maximum build the API in hindsight of once this moment comes, and this moment will come, that it is cheap for us to migrate to smaller pieces of data, for example. So we don't from day one have one single mega query, but maybe slightly more into the direction of, okay, we know for sure this is going to be a primary model, right? Let's do it already there roughly, that we fetch this in isolation. But I wouldn't do much more. It's, I think, much more beneficial for you to know what could happen and for you to come prepared a little bit, to know when it's going wrong, and for you to schedule early that something needs to change right now. And luckily, you already know the solution to it. And so you should be able to move quickly, I hope. It happened to me over and over again. When I built something with my colleagues, of course, where we knew some issues are going to happen in the future. No idea when, but we knew the potential bottlenecks. But we also knew, I had a rough idea already about the solution. It's just the solution was so complicated at that moment in time that it was unfeasible for us to just straight up, okay, let's fix the future already, you know. So we didn't go for it, but what we did up until the point where it inevitably failed was work a little bit in hindsight of this. So whatever we build right now, that once that moment comes that we're not completely screwed, but that we can, okay, we just need to move from here to here and then from here to here, and then you can work your way around it. Happens very often for us. Does that answer your question?
Yeah, that's great. Thank you.
Yes?
Yeah, I would like to throw in a different angle on this. I'm not particularly familiar with GraphQL, but how well does it perform with server-side caching? Say, for example, you put the Redis cache in front of it so that not every query has to hit the database all the time.
Yes, so unfortunately I have no clue if there is any kind of tooling available. I'm not sure if I would recommend you, even if I knew, to split up a GraphQL tree into multiple pieces, have one piece be part of Redis or whatever. But as far as I'm concerned, if you play well with frontend, and you have one query that sends off this one piece that you want to put into Redis if the frontend behaves, and they only do this, everything else they fetch separately, then you can just put this into cache however you want. It doesn't matter if it's REST, doesn't matter if it's GraphQL. It's a request at the end of the day, input, output.
Yes, that's what I thought. Did you use any server-side caching?
Not yet, but we do intend to.
Okay.
We do intend to, yes. For inter-server communication. One server needs to fetch data from another server. This is why the user piece that I mentioned before is extremely expensive for us, because it's coming from a completely different location. It is an actual network request that the server has to make. And this, for example, we just want to cache. And I am not a backend engineer, but last time I heard from this backend engineer in the corner, the Elixir wizard, it should not be, so GraphQL should not be the thing that is holding you back here at all. It doesn't actually matter. It's just a query language.
Yeah.
It's just a way to say, I want to fetch this. And we have this kind in REST as well, but in different ways, right? The URL part, this model, this ID, etc. It's the same thing, essentially. All right, I think there were more. User?
Have heard about Graph CDN?
No?
It's like a CDN for GraphQL queries. It's by Mark Steuber Co. So it's like a CDN for GraphQL queries.
Can you spell it for me, please?
Graph,
Graph,
like
okay.
GraphQL, CDN,
CDN.
Content Delivery Network.
Yes, okay.
So they are especially for
Let me share this with you.
caching GraphQL queries, etc.
Excellent, thank you.
So because my understanding, especially on GraphQL, is it's mostly dealing with the problem of underfetching, overfetching of data. That's one of the main problems with REST APIs. So because some examples you showed with GraphQL queries, if they get pretty large, so there is no way to cache any data for queries like that, so you have to split them up again. And so then just came up that it's more important that you just fetch the data, the properties you need of a model. And I think that's the most important thing compared to REST APIs.
Yeah, thank you.
Because if you have a query with like 10 models you want to fetch in one way, you're also waiting like, I don't know how long.
Yes, absolutely.
And it doesn't even matter then if it's REST or GraphQL.
Excellent. We have more questions, I take it, or do we want to?
Let's do one or two more. But no, that's not a good metric because it can extend, right? But let's go ahead.
A relatively small question. With the complexity of the algorithms for the fetching, how did it change going from the original to the improvement steps up until the parallelization? Because then this depends also on the hardware.
You mean the query complexity?
Yeah.
Which you can configure, like you are not allowed to go more than 5 levels deep or whatever, stuff like that. It went better, right? Because we're not going super deep anymore. We're going this level straight away. So the query complexity quite drastically reduced for the critical pieces of our app. For everything else that was not super critical for us, we still appreciate to just say, man, just give me all of this stuff, right? For those cases where the performance there is perfectly.
So did you quantify it with any O notation or no notation?
Like you want me to give you
No, just asking.
Percentage promise of
Yeah.
how much faster your app can be. I deliberately did not put this in here.
Okay.
because I would have to lie to you. It completely depends on what you're doing, what you need to do. It completely depends on, like, if this thing makes it easier for you to resolve from local state, for example, like, then we need to talk, right? Do you have a WebSocket connection that continuously receives state updates, which you then can use for your to skip fetching altogether, for example? If you don't have this, for example, then any number that I give you is kind of like, you know, irrelevant. I would just suggest to you, if you find this approach interesting, just try it yourself really quickly and measure it yourself. Like, don't take it from me, you know. Maybe what I'm telling you is the complete opposite way of what you should be doing, right?
Thanks.
Okay, one more, I think it was.
If you have any.
Yeah, if you don't mind.
Yes.
So were you ever considering using a different client on the client side, like, you know, Relay.js, for example? Like, a lot of these problems that you mentioned, I feel like can be solved using, I mean, at least when we are using like Relay.js for almost 5 years now, and
Yes.
we have a normalized data store, we have global IDs, we have all of this in there. So a lot of these problems, I feel like, can be done already by just changing the library, I believe.
Yeah, so absolutely. Before you go do any of the manual stuff, have a look at Relay, have a look at Apollo, have a look at your cool, 100% for sure. They do help with a bunch of the things that I mentioned, with cache exchanges and whatnot, you know. That wasn't particularly the point of my presentation, though. The point of my presentation is more like, these tools won't help you from bad GraphQL design, right? And if you do have great GraphQL design, then you even more so can make use of these tools, because splitting up queries, like I mentioned before, GraphQL has no understanding of supersets or subsets or whatever, right? So not even Apollo, Relay, or anything like that can help you with that. They can help you if you have good schema design. Then even more so, they will help you out on. You can use this in combination with Relay as well, I take it. Like, you can have small stuff inside Relay and you fetch it like that, what I mentioned before. But if this is not a concern of yours, like if you use Relay and you're happy with it and you're not having any kind of issues, then ignore what I'm saying, please.
I learned a lot from that. So.
Okay, then.
Very good, yes, let's do a pause until prime time, so 8:15. Let's grab some drinks, bio break, and let's pick it up.
Thank you.
Thank you. Yes.
It takes one to actually burn it off.